Okay, now we come upon problem number 13. An absolute value inequality is shown. What is the solution set for this inequality? Okay, I'm going to show how we did this by hand in class first. Okay, we did 4 steps. The first thing we did was we isolated, then we split, and we solved, and then we check. So let me go through this really quick. You got to get the absolute value, which is this which is 6 minus 2x. That absolute value expression has got to be isolated by itself. So in order to do that, I got to get rid of this 4, and I got to get rid of this plus 8. So subtract 8 from both sides. All right. Once you've done that, 24 minus 8 is 16. Then I'm going to divide both sides by 4. Because 4 is being multiplied times the absolute value. So divide both sides by 4. Once you've done that, then the absolute value of 6 minus 2x, the absolute value is greater than or equal to 4. You have isolated the absolute value. It's by itself on the left. Now that you've done that, you get rid of the absolute value by splitting it. If the absolute value of 6 minus 2x is greater than or equal to 4, then either 6 minus 2x is either bigger than 4, or 6 minus 2x is actually less than negative 4. So this should be a less than or negative 4. That's how you split when you have an absolute value that is greater than a number. So let's go ahead and go through this. On this side, when I'm going to isolate x. So I'm going to subtract negative 6 from both sides. I'm going to do that. Then once I do that, I subtract that. I have a negative 2x is, it was greater than equal to 4. But once you divide through by negative 2, you have to switch the sign. And technically what I should have done, and this is still fine, I really should wait and switch the sign at the last once I do the division. Now once I've divided by negative 2 on both sides, then I reverse the inequality, and that's how I get x is less than 1. Okay, so let's do the same thing on this side. All right, we have 6 minus 2x is less than or equal to negative 4. So again, we subtract 6 from both sides. When I divide both sides by negative 2 to get the x by itself, that's when I reverse the inequality. So now I get x is less than 1 or x is greater than 5. Now to make sure that these are the answers, the next thing after we did the split and then the solve, then we did the check. You pick any number from this interval. Give me any x value that's less than 1. I use 0. Put a 0 in there. Do you get something? Did you get something that's true? Yes. So what about 10? If I put 10 in there and then I substitute 10, what am I substituting in? I'm substituting back into the original equation. So I'm putting in a 0 for x here, or I'm putting in a 10 in there to see if it makes sense. And if it does, then good. All right, and here it does. Now, that seemed like a lot of work. So I also showed you how to do this on the graphic with Desmos. So if you go to Desmos, let me find my Desmos, there we go. And let's look at same problem here. Okay, first of all, let's graph it. So if you graph it, it automatically tells you what the answer is. Notice that this side, I'm going and just go back to the home zone. I clicked on the home to do this. Notice that if I just read the shaded area, what is it saying? This shaded area is saying x, look at the x-axis, x is less than 1, including 1, because that's a solid line. All right. This shaded area is saying x is greater than 5, including 5. So check it out. See, exactly the same thing. So you could also get the answer just by graphing the inequality and just reading the answer, reading the shaded area. And that completes this particular exercise.